Mancala is a very complicated game, yet it has, if you play with the basic strategy, then it's kind of set who will win. The first player usually wins, but we don't really know why, and we haven't been able to explain that mathematically.
So it's like Hansel and Gretel. When you play, you leave a trail. So therefore, you can always trace back to where you came from. If I had 100 stones, could I find the 100-stone board without tracing back 99 times, or 100 times, I guess? So one of the colleagues here at JMU found out how to do that, find that board uniquely, and then these students have used kind of some of that information to be able to find any board, given not only the board, but also the moves that get to that board.
I've never done any math research before this experience, so this has been the first time I've ever done anything like this, and it's been very eye-opening.
It has helped with the trials and tribulations of research, how to deal with getting stuck and self-motivation, self-direction. This is much harder, even though some of the stuff, after we've derived it, it's not that bad, but just deriving things for the first time is, in an original sense, it's much harder than working through a more complicated problem in a textbook.
They'll have written a talk and they'll have written part of a paper, and then we'll probably help turn that paper into something that gets submitted to a journal and will get published, assuming that we get enough results to do that.
We already have them.
I think we do, yeah. They already have written like 10 typed pages of serious math results, so they're on fire. Yeah, and then probably they go home at night and they still can't get it out of their brains, and then they wake up in the morning and they do it all over again.